Hi Enigmas. So let's solve LeetCode 287 today, that is find the duplicate number. Okay, so in this question we are given an array integer nums and it contains n plus 1 integer where each integer is in the range 1 to n. Okay, and there is only one integer that is repeated, that only one integer, its occurrence can be more than one, rest of them are only of single occurrence. Now we are given the constraint that we don't have to modify the array and use constant extra space to solve this problem. Okay, so if this constraint was not there, the quite simple n log n solution would have been we could have sorted this array and we could have checked for I and I plus 1 position. If next element is same as the ith position, then we could have said this element is the repeated element. For example, here we could have checked 1 with 3, 3 with 4, and 2 with 2. As soon as we reach 2, we would have found these two are same, and we could have written that 2 is the answer. Now, since we don't have to modify the array, that is we can't use sorting or anything. So let's look at what other methods we can use for. So one thing we know for sure that we are provided the constant range of values that will be there, that is 1 to n. And so our answer will be from this range between 1 to n. And occurrence of all the numbers will be 1 except for 1. So this slightly gives the intuition of something like binary search, as we have a defined search space that is from 1 to n, and occurrence of every number is 1, that is we know the frequency of each number. So let's see how we will implement binary search on our given array. For example, let's take the given array as this one, that is 1 3 4 2 2. Now we know our search space will be from low to high, and highest value will be size minus 1, lows will always be 1. So we know our search space is 1 2 3 4. So mid value will be low plus high by 2, that is 1 plus 4 5 by 2, that is equal to 2. Now after this, what we will do is we will iterate through the given array and count the number of elements that is less than or equal to the mid. What will happen from this is, if the answer lies in the first part of the search space, then the number of element whose value is less than or equal to mid will be exactly equal to mid. And if it is not, then the answer lies in the first part of the search space. Otherwise, it will lie in the second half. Let's see how mid will work on this. So we will iterate through the whole array and count the number of elements that are less than or equal to 2. So we will see that 1 and these two 2's are the only 3 elements which are less than or equal to 2. That is count will be 3. Now, as we discussed earlier, we know that this count is greater than mid. This implies that our answer is going to be lying in the first part of the search space. So we will shift our high to mid, that is 2, and low will remain as it is. So our new search space is from 1 to 2. Now the new mid value will be 1 plus 2 by 2, that is 3 by 2, which is equal to 1. And we will count all the elements that are less than or equal to 1. So we found that our new count is equal to 1, as only one element is less than or equal to 1. Now we know that the count is equal to mid value. This implies that the answer is going to lie in the later part of the search space, that is this one. As there is only single element left, so we will know 2 is the answer for our given example. Now let's quickly code it up and see how this works. Alright, so we will initialize the variables here. Low is equal to 1, high is equal to size minus 1, and we'll initialize a variable mid. Okay, now we will start our binary search while low is less than equal to high. We will initialize mid value, that is low plus high by 2, and we will iterate through our whole array to initialize the count. Before that, we will declare a count variable every time 0. And now if if num is less than or equal to mid, we'll increase our count. Alright, we have taken the count of the numbers, and now we will see that if count is less than count is greater than mid, we'll move our high pointer to the first half of the array, as we know that the count of number in the first part of the array, that is less than or equal to mid, is greater than required value. So we'll shift our high value to the lower part. Otherwise, we'll move our high pointer to the later part, that is we'll shift low to mid plus 1. And yeah, in the last, when we'll come out of this loop, we'll return the low pointer, which will be pointing to the only integer that is repeated more than once. Let's run on the given test cases and see. Okay, some typo here. Nums dot size -1. Okay, so we are getting time limit exceeded. We will remove this value from here and let's run it. As it was less than equal to, so we will keep repeating in the same loop, and this condition will never satisfy. Yeah, so it has been accepted. Hope you got the solution. In case you did, please like to the video and subscribe to the channel. Thanks for watching. See you in the next video.